Welcome. My name is Brock Henderson, and this is Ashton, and we are the co-chairs, I guess, of the NoCo IGDA here, and we try to have like monthly meetings. This is the first one in Loveland. We've had two up in Fort Collins before, but see some new faces. Welcome. Thank you for making it up here in the cold. So yeah, we try to do like a monthly meetup, and so you're welcome. Please join us. Tonight, Numinous Games here in Loveland, which I'm a part of. We are going to give a presentation about Untethered, which is a recent mobile VR game that we made this past year. And so, let's get started.
I don't know why I keep up here. Sorry.
No, thank you. Do you want to start?
Sure. So first, play our trailer.
Yeah.
Oh, yeah.
This is the trailer for our game. Oops, wrong way.
Late night in a town that goes to bed early, one DJ sits alone in a seaside radio station.
30 seconds till you're on air reading your live lead.
Well, practically alone. There was the producer. It's hard to ignore that guy. The DJ's heart began to race because in just 17 seconds they'd be on air. 13 seconds now. 11.
Howdy, stranger. Need a tow?
Are you awake in there? We have dead air. Just read your script.
Just then the DJ remembered that the live lead was on the orange page.
Wait, am I supposed to talk?
That was inspiring. Don't you go leaving me to take a run at an acting career.
Well, a 9-pound hammer is a little too heavy for my size, buddy, for my size.
All right, and I'm sure you guys have all heard of this because it was a huge hit as we released it on the Daydream platform, and they showered us with downloads. I'm Ryan Green, and I'm a member of Numinous Games, and I'm one of the directors on the project, which means I did a little bit of everything, or I was part of everything, even if I didn't do everything, whatever. So I drew the straw of presenting the presentations for the members of the team that couldn't be here. So we have Josh, who served as the art director and co-director, and I took some of his notes, and I'm going to make my way through that. And then also Amy, my wife, who is our head writer, and she was responsible for the writing on the project. So what is Untethered? Untethered is a narrative experience. At Numinous, we tend towards narrative experiences, which are kind of odd and quirky, and they don't really follow convention, and we like to experiment. So what we're going to show you today with the Untethered project is how we experimented with narrative, and how we, the things that we attempted. And so we're going to start with art direction. So, let's see. Next slide. Okay, so for those of you who know, we worked on our previous project was called That Dragon Cancer, and one of the more notable things, or if you're not aware of that project was a narrative experience retelling the story of Amy and my son Joel, who passed away to cancer 3 years ago now, and we worked on what ended up being a memorial to him and his life. And our experience loving him and losing him and all that came with it. One of the kind of stark characteristics of the art style of That Dragon Cancer was called like a low poly approach, and we focused on low poly models, or what appeared to be low poly models, with a lot of flat surfaces and a lot of faceted designs, kind of harken back to like the PS1 days. But very stylized and very full of light. And so even though it was rather abstract, we didn't have faces on our characters, we had a lot of flat surfaces, our bushes and trees and all these elements were very impressionistic. It was full of light, and we used a lot of baked lighting and a lot of high-res textures. So I don't have an example of that, but I can show you, or if you're interested, I can show you another time. Keep on richness and fidelity. But the thing that I wanted to talk about there was that we found that it didn't matter that we had a lot of detail in the art design. That the style, it didn't matter that we didn't have faces on the characters, because we had such richness in light and audio that it allowed people to, we found it allowed people to kind of fill in the blanks. And so that's the first thing that we want to talk about when we talk about our approach to VR, is that from a technical perspective, the industry is playing catch up to the requirements of VR, right? So like for desktop VR, you need a new system and you need like $400 goggles and everything else. And for cardboard, you have all these low-end phones that don't have really awesome specs. And so what you find yourself is not only designing for mobile, but designing for mobile at half res, because you have to display it for 2 eyes. And so in that case, chasing realism in your art direction is probably not the wisest thing to do. And so what we chase is richness, right? And what that means is that we choose a distinct art style, and we're going to explore that here. We focus on using the richness of light and the richness of audio to really create what feels like a high detail environment, even though it's not. So that's what we mean by richness over fidelity. Just don't chase realism. Okay, go ahead. So like I said, VR for mobile is an exercise in restraint. When we're talking about 35 to 45,000 polygons or triangles per eye, that can get really restrictive. And so when you start thinking about these large expansive landscapes, you're just not going to be able to do it. And if you did, you're going to have billboards rather than full trees, because you just don't have, the space. Also, another constraint is we try to keep things under 100 draw calls per eye. And what that means is how many draws to the screen it takes to create the image. And so when you have a lot of overdraw, that is a lot of transparent things. Like say you have a window and you're looking through the window to something else. That means they have to draw the entire screen twice to be able to create that image. One for the background and one for the transparent object in front. And so what that does is that means that your phone has to draw millions upon millions of pixels times however many draw calls you have every frame. And what you want with VR is to stick to like 45 to 60 frames a second. And so because of that, you're really constrained. And not only are you constrained by the GPU and the limited GPU on mobile phones, but you're also constrained by heat. And so if you push your phone too hard and you push it to the limit as far as the draw calls and your CPU and everything else, and you're just doing a ton of stuff, physics and everything else, and sound and all that, then you're gonna overheat your phone. And once you overheat your phone, it goes into performance saving mode and just like throttles you, and you make your player sick. So when we're talking about everything from here on out, we're talking about playing within restraint and trying to find creative ways to maximize that. Okay. So first thing I want to show you is some of our early art direction. And so because we knew our constraints and because we were looking for ways to kind of mend that low poly aesthetic that we discovered in TDC, but we were also trying to solve the problem of when you're doing a lot of lighting, you can't do real-time lighting. And because every new light adds draw calls and it adds complexity and everything else, right? So we were experimenting with low poly. And we were experimenting with textureless. So we were just using gradients to fill the space. What we liked about it is that it was very minimalist. It allowed us to focus on the narrative over the environment, and the environment just left an impression. However, as we tried to add detail for things like sliders and buttons, because you're in a radio station in the first episode, it started to get more complex. And the other thing that we were relying on in this kind of art style was a lot of shadows. And shadows add draw calls. And so when you're thinking about creating these environments, like, yeah, those things come into play. So we had to move away from this style. And as we were exploring, one of the styles that we really liked is a gouache. Now, I'm not as familiar with it because I'm not the art history major. That's Josh. But I pulled some Google images with the gouache keyword. So if they're not truly gouache for you art nerds, I'm sorry. But what we liked about this is apparently it's a style that uses watercolor with white mixed into it, so it like looks less transparent and translucent. And so you get these like solid colors. And you still have to play with the color palette like you would with watercolor. But what we liked is it had that impressionistic look that we were familiar with. And so we searched around, we did a bunch of art tests, and we stumbled across this artist named Ben Shipper. And he produced some lovely concept drawings for us. And so we were using a lot of that wash and the rich gradients and really focusing on just like the shape and the color of things first. And then adding the detail in the line work. Because what we were starting to move towards was a more comic book look. That's what we were attempting to do. And so let's see. Okay, so move on to the next slide. This is a reverse look of the colors are a little bit off, but if you see it on here, it's gorgeous. So you'll see that it feels like a comic book, but it differs from common comic books in a few different ways. And the thing that we like about the ghost style is that it kept the images light soaked and light filled, and allowed us like this very muted and beautiful color palette, and kind of gave this feeling of what we were going after was like this northwestern town in Oregon, where everything's kind of rain drenched. So if you move on to the next slide, the difference between a more classic comic book style and the gouache style is that with the comic book styles, a lot of times you start with the ink first and then you color later. And so like a lot of the shadows are really heavy with the ink, and it ends up like looking a lot darker and more, I don't know, gritty, you know? And so I, pull up, this is Walking Dead and The Wolf Among Us from Telltale, which is another narrative experience, but this isn't quite the feeling that we wanted to communicate with the space. So we wanted mystery, but we didn't want it to feel dark. So, one thing Josh wanted us to note in this is that he just wanted to emphasize how important fine art knowledge is to art direction, because it both helps you identify like what style you're going after and allows you to communicate that to artists. Because any digital artist that works in games is going to be able to match styles. And the more you can do with both telling them what the movement of the art was that you really like, as well as examples, the much closer you're going to get to your desired look and feel. So, I'm losing my notes. Hold on a second. Okay, so we can move on to the next one. If my app will let me. Let's try on my phone. Okay. So as you can see, this is actually a screenshot from the game. And you can see that what the art department, Josh and Jordan, did with his drawings. They really did a good job of matching it. And there we go. Okay. So some of the things I wanted to point out here as far as in the style is that there's some difficult challenges in getting this kind of style. One is the textures. We have the texture space, and you want to make sure that you have a minimum amount of textures for the requirements of the phone. And I think we were targeting about 1 gigabyte of RAM or so with the art, because we were using new phones and we were targeting like the latest from Google with their Pixel phones. But a lot of these lines here had to be drawn over the top of the mesh. And so what you see is you see a mesh that has a texture on it, and then you see another mesh which is like an outline of everything that has a line texture on that. And by doing that, we were able to have really nice looking lines in VR that had like a lot of density in pixels. and allowed us to have nice clean lines that also had this like charcoal type feel to them. And so they looked hand drawn. And so if you want to try the experience later, you can kind of see that in the headset. But what it did is it introduced overdraw, which means that the lines are sitting on top of these things. And so the phone has to draw those lines more than once. And so that's one of the limitations of like a more line drawn style, is because if you use just textures, you're going to get really low res lines, and they're going to look really crummy, and they're going to look really pixelated. But that's one of the trade-offs that we really wanted. So it's one of those things that we had to be very careful about. And it required some deeper knowledge, like it required technical artist knowledge more than just like conventional knowledge, where we had to write some shaders and get a little bit lower level to maximize the performance. So go ahead and move on to the next. So the problem with this is that, you know, the more visuals you add, the more you realize like this is just a simulation, this is just a drawing. It's not going to have the richness, and we're trading off things like these trees are a mix of billboards and real-time meshes, because in the second episode you're driving down a road. Now remember, like, we can't have open world environments, and so what we had to do is we had to generate the road ahead of us and curve the road in the shader so it looked like you were turning. And like we had to use tricks. And so I think when you're designing the narrative, keep in mind that when you're designing the narrative, you have to have an art direction that makes sense. So by putting it in a northern Oregon town, it's really foggy and you can't see very far. And so that helped us with that. I think also, I mean, just with anything with mobile, like we've seen it with, you know, like Eclipse the Edge of Light was another one on it. It was a beautiful game, but the more you tried towards reality and the bigger the maps got, the less dense you could make it. And so the trade-off is that if you have a really large map, you have a very sparse environment. And if you have a really small map, you can have a very dense environment. And so we tended towards creating a narrative in which you could sit in one place. All right, next. And so the other thing is that we wanted everything to be mechanical and have, like, you know, if you're inside a VR environment and you're just staring at a digital screen, like if you're simulating a computer inside of VR, that's kind of silly. We wanted there to be a tactileness to that. And so we tended with the production design to go towards a more analog alternate future where we still had the buttons and we still have the dials and we still have the sliders and everything else. But that also creates a lot of visual clutter, but also a lot of visual clutter in the things to do. And so you have players searching for all the things they can click and the things they can do, rather than listening to the narrative, and we'll talk more about that later. Another little trick that we did by kind of baking the lighting, you can go to the next one, baking the lighting into the environment, is that just by changing the color tone, we can make it look like you're at night rather than during the day. And so that was a trick that we used in TDC, where we'd either lurk between a daylight light map and a night light map and simulate lightning or simulate a change in color, and we didn't have to use real-time lights for that. So if you're thinking about using real-time lights, one really nice trick is to bake it in both lighting setups first and then move between them, like blend between them. That will save you a lot on performance. Okay, so that's art direction. Anybody have any questions on art direction? Yes?
When you were talking about you wanted to keep the 1 gig,
We got 1 gig of RAM, yeah.
was that per scene or for all the?
Per scene, because we can load things in and out.
Okay.
Yeah. But when you're dealing with phones, you're dealing with like limited resources, and so you have to budget between the art assets and the audio assets. And in Unity, you also have to be very careful about that, because if you use Unity and you're dragging audio files into the scene and you're making references to them, then when Unity loads, it will load all that audio into memory. And so that overhead hits you right away. Whereas if you have an audio engineer who can program, then he can load those as he comes in, and we'll probably talk more about that stuff later. But just be aware that you have a limited budget and it's shared between multiple disciplines.
Was there like some output thing that you could watch when you were moving things around the scene to make sure it always stayed within whatever your ideal limitation was? like a counter or something like that?
Like a counter, a physical
No,
counter, or
like
like
it's
a
counting the number of
profiling?
Yeah, like is there some like real time maybe? Because like let's say you want to move something around or adjust something,
Yeah.
that could change everything. Like,
Yeah,
how
I
do you-
mean,
how do you
it's important to
keep
profile.
track of that?
I can just kind of leave it at that. It's important that you build to your phone, and that you look at it in VR. I think one of the biggest mistakes that I think one of the struggles we ran into is how little time we spent in the headset. And that's really vital with VR, is because when you're thinking of the biggest differentiator, honestly, or one of the biggest differentiators, is scale and reach. And when you're limited with these headsets, these controllers are 3-axis. They're not 6-axis. So you can't go like this. You can do a pointer. It's like a laser pointer. And so with those limitations, it's limited to how you can reach and how you can interact with things. One thing that Josh did is that we had a counter space. If you go back to the radio station, we had a counter space in front of the player, but we couldn't do this, right? The controller's permanently at waist height, and so we had to do things. If you imagine a laser pointer coming out this and on a table, if I want to pick up the box and this is in the way, then I can't move it out of the way. So we had to do some various tricks for comfort and ergonomics. And so again, it's really important to test with a controller. It's important to test in the headset. And you can set up a similar setup if you have a Rift, and there are some libraries that simulate 3-axis. But that's really vital. And especially with the older, like the Gear and the Daydream headset are also 3-axis. So all you can do is rotate your head. You can't lean. And that's honestly one of the things that bit us in designing for this, is we were designing for the min spec, which means that we had to make some trade-offs. And so like room scale VR was kind of out in our design, which means we can't really adapt to room scale or the new technologies that are coming out, because we were stuck on 3-axis on both. So something to be aware of. Okay. Any other questions? Move on to narrative. Okay, so I'm also filling in for Amy. And Amy and I worked on narrative together. Amy and I wrote on That Dragon Cancer, and Amy really took the lead on writing this episodic series. And so we had originally planned on 6 episodes. We moved that down to 4. And so she wrote the first 2. And I'm going to talk about what I'm calling a conversational approach to narrative. And this is one of the experiments that we wanted to test in designing for narrative experiences. And what I mean by that is the next slide. That it's a continuously flowing narrative that expands and contracts as the players interact and as they speak, because we have voice input, right? And so a lot of times when you think about narrative in games, you're thinking about like, well, I either have an environment that I explore by finding audio diaries in it, so found objects that have audio attached to them, or I talk to an NPC, but that there's a lot of time where the narrative just isn't happening. And what I wanted to do was design an experience which was constantly talking to you and constantly telling you a story, but reacting to your presence. So if you need kind of a real life analog to that, the next one would be think improv. So how many of you have ever been to an improv show? Cool. So you know that when they ask for a volunteer, they ask for a premise, and the audience gives them the premise, and they go off of that. Sometimes they'll bring up a volunteer, and they'll sit them in this premise, and they don't know what they're going to say, and or the improv players are ready to watch what the volunteer is going to do and respond to it. And so there's a lot of rules about improv, and I won't get into many of them, but one of the key ones is this idea of saying yes and, and so taking what they say and saying, oh, you said this, now I'm going to play along, and I'm going to go with you in this narrative. And so what ends up happening when it works really well is magic, right? Because the players were able to anticipate what the volunteer was going to do. Everybody laughs. There's these really special moments. And that's kind of like, and when it doesn't work, it's terrible. And everybody laughs anyway because, like, that's the game, right? And so in that space, I wanted the improv and those like theater perspectives to really inform how we designed for this. And so we tried, and so it has a few net effects. When you do this, when you're constantly thinking about telling the story and adapting to what the player does, you can move on, the narrative decision points disappear. And what I mean by that is that a lot of times in games, you're going along, da-da-da-da-da, you hit an NPC, you click A for the NPC, gives you the thing, and you talk, and you have like this question-response interaction that happens, right? And then you move on. However, in the model that we were chasing, you didn't know when your input mattered. You were just having a conversation with the NPC. And so at some points, the NPC might be saying something, and you pick up a cup. Well, once you pick up the cup, he interrupts what he was going to say and says something about the cup. And then when you put the cup down, it goes back to what he was talking about. So the net effect is that the player thinks that their playthrough was the playthrough of the game. They don't know all of the nooks and crannies they could have explored had they behaved differently. So this has some positive and negative repercussions. One of the negative repercussions is that people didn't know that their input mattered. And so even though we were anticipating their keywords and we were anticipating what they were saying, what they were going to do, they didn't know that there's a different playthrough possible. So that was one of the things we struggled with. Next is that players are free to explore a sandbox while the NPCs respond to them. So in VR, a lot of times these VR experiences tend towards simulation. What I mean by that is they give you a room and you can pull all the triggers and pick up all the things, and that's what you're focused on, is exploring. But while you're exploring, we're also trying to talk to you. And how often when you're working on something and you're very intense and you're typing or something, and a coworker or a friend comes up to you and tries to ask you a question, and you look up and you say, "What?" because you weren't focused on that part of your brain. So that's one of the challenges that we have in narrative for VR, is that we both want to give players something to do, but we also don't want to distract them so much that they can't understand what's happening. And so a lot of times what we found is that in the experience, that players remembered how they felt, and they had a vague recollection of what happened, but they couldn't tell you what exactly was said. And so that was an interesting trade-off for us. And part of that is that when you're in a game, people are conditioned to want to do rather than to wait and to be present in the space. If I'm having a conversation with you and you're talking to me, I'm probably going to put down what I'm doing and talk to you. Well, hopefully. I have a bad habit of that. But if I'm being nice, that's what I'm going to do. And I'm going to give you my attention. So there's this constant request and response of asking the player for your attention. So how do we accommodate that? How do we explore that idea of a narrative that expands and contracts to what you're doing? Some conventional things that we tend towards are what's available to us in the film world, and what's been made available to us in tools like Unity is something that looks like a nonlinear editor. If anybody's done film, you'll recognize this. These are all the cues. You line them up on a timeline, and they happen when they happen. And so you can play audio, and you can move the camera, and you can adjust the lighting, and you can move things around, but it's all constrained to a timeline. And it's not very good at waiting for something to happen and then responding to it. So this is really good for cutscenes, but to move beyond cutscenes and narrative, you have to get more in depth. So the next one. So, oh no, you can't see it. Okay. So UX design, yo. Okay. So in a conventional NPC dialogue interaction, this says, the NPC says something. And then the player chooses a canned response from a list, like A, B, C, or D. And then the NPC responds with A, B, C, or D. Then it checks if it has anything else to say, and the loop repeats. So think typical narrative trees in adventure games. Where what I was frustrated by is I would go through them, I start with A, and then I'm like, oh, I'm not going to skip B, C, and D. I want to know what they're going to say. And so I have to ask B, C, D, and D, which really breaks the flow of the narrative and really breaks my immersion, because I'm just optimizing for making sure I didn't miss anything. And that's not what it's really designed for. It's designed to have a conversation, but it has the net effect of always causing me, at least, to always drill down to every possible response. So go ahead and go next. So what if we could, so one of the questions we asked is, what if we could interrupt an NPC? So we thought of this as kind of like a conversation train that you could derail and then you could get back on again. So again, you have this NPC says something, player responds with their voice. So say they ask a question and the player responds with a response. And because it's a question with a narrow set of possible responses or anticipated responses, we can pick out keywords and say if I said, who was the last person you fought with? What would you say? Like your spouse or your partner or your brother or your mother. And so we can anticipate those common responses and then have a canned response for that. But then what you can also do is that as they're talking, you might pick up that coffee cup. So when you pick up the coffee cup, they're going to acknowledge what you're doing, say, why aren't you listening to me? Or talk about how bad the coffee is in the studio, and then resume with what they were saying and continue that loop. So that was a theme in something that we tried in episode 1, is could we have a narrative in which you're the DJ in a radio show that's going to go 30 minutes no matter what, or 30 to 45 no matter what, and the show's going to go without you, with or without you. But how much you're involved in the show will change what you hear and what the producer says and what happens and in what order. And so that created a space, a constrained space in which the player could be. So go ahead to the next one. All right, so what if in episode 2, where you're a truck driver and their sole job is to drive the truck when you're paying attention, is that could we anticipate what the player was going to say? And so can we ask them open-ended questions in which we can anticipate what they're going to, how they're going to respond? And with that magic trick of being able to, because we were using voice acting, this wasn't just text-based, and so we had to pre-record every line that we had in the game. Could we offer enough of a variety of responses to make the player feel like it really responded to them? If they said something about their mother and then the NPC in the back seat responded, then that seems magical. And then the last thing in episode 3, what we were exploring, is what if we asked players what they thought about their actions? And so this less focused on paying attention to what they say, but based on what they're doing, prompt them with how they feel about it. So in episode 3, which we were working on, you were making s'mores at a fire. And so depending on which tools you were using and if the marshmallow was burning or actually you were in a competition, then they would ask you like, hey, how do you feel, or how do you feel about this scenario? And you would respond. And so those are some of the different ways that we were exploring this. So there's been much more that could be said about that. Here, let's see. But I want to move on here. Two tools. Okay, and I just wanted to talk about, so as far as the experiment goes, we had to find the tools that would allow us to do this. And so one of the areas we explored was a tool called Ink. This is something where a writer that's not necessarily a programmer can learn basic programming language that allows them to create interactive narrative. And it's kind of like Twine, which is I'll show a link to in the next slide. But the idea here is that when the player does something like picks up a coffee cup, then the producer can respond. And when they pick up the takeout box, then they can respond. And so what we were able to do with this was kind of model how the producer would respond to different actions and different inputs from the player. But what happens in Ink is that when you play an Ink script, what you're playing is from a command line or a script. And what happens is it plays the script, then it asks you what you want to do next. Then you choose something, plays the rest of the script, asks you what you want to do next, and plays it and asks you what it wants to do next. So what it ends up happening is more like choose your own adventure, just a little bit more complicated. But what it fails to do, or what it's difficult to do, is really model what it is to interrupt a character and have them rabbit trail onto something else, and how do they circle back. And so a lot of the complexity that starts to come out there becomes very difficult to communicate. And that was one of the troubles we had with Amy and I working, is that trying to figure out a way to communicate best to the programming team how to do what we wanted to do. And so we ran into limitations. And one thing that Amy wanted to say is that a lot of times with these tools, because of the way that they're designed, you find yourselves all making the same kind of games and falling into the same patterns of storytelling. And what can happen is that either because you're a programmer and you're used to that, you don't often think about what other types of narrative can be told. And that's one benefit that a writer who isn't a programmer or who isn't like an engineer can offer, is they can offer different perspective and different ways of modeling narrative and kind of push the limits on that. So what I'd encourage you to do when you're thinking about writing is that if you're thinking about experimenting like we are, that it might, some of these tools are great, but they also kind of limit the style of narrative that you want to create. So go ahead and move on. Okay, Twine, another one, it's great. You can write it the same way as you can ink. It also has a visual editor that allows you to drag and drop things. But I find that as the stories get really complex, it gets really spaghetti. And so I like the clarity of code in these scenarios. So for Twine and ink, you have a code option. All right, next. Okay. So this is what we landed on. And we're going to talk in more detail about this later. But we landed on this idea of behavior trees. And they're a specific AI pattern that we found in our research. And these are the kind of things that you can do with behavior trees. You can serialize, or you can order up things that happen one after another, right? Or you can make multiple things happen in sequence. And so when we think about like our nonlinear editors, like Adobe Premiere or Final Cut Pro or whatever, you do that. You can create tracks for things that happen at the same time, and then you create sequences for the things that happen one after another. Behavior trees also allow you to have things happen when certain things are true. So when, if the player is not picking up a cup, then there's one path, and if they pick up the cup, there's another path. And if you move on to the next one. So for sequences of actions, those are really good for like character dialogue and cutscenes. But those don't really involve the player at all. So move on to the next one. And these are great for, like you said, being able to sequence a bunch of different things. Lighting and movement and choreography and camera and animation and all of that stuff. And so go to the next one. And this one is really good for, well, I already explained it. So what's great about behavior trees is that we found that it fulfills all of those different patterns. Being able to sequence things, being able to do things in parallel, and be able to wait until things are true to move on. And so what that allowed us to do is have these large trees which allowed us to react to the player and react to events, wait for things to happen, for 20 seconds before failing out to a predefined default, anticipate different the player's reactions and react differently based on their keywords, and everything else. So there are a few tools for behavior trees, and we're going to talk about them, talk about our implementation of behavior trees later. But I just wanted to point out there is a visual tool for doing this kind of thing called Node Canvas. But what we found, as you'll see later, is that visual tools don't allow you to get very complex before they start to become massive tangles of spaghetti on visual charts. And anybody who's worked in Unreal Blueprint, I bet could probably like attest to this, is that it's not a really great way to code because of how much real estate every action takes. So we ran into some limitations on that, but this is really good for getting started in the thinking, putting yourself in the mindset. And then we ended up using an implementation of fluent behavior trees, and we're going to talk about that a little bit later. So that's all I got. If anybody have any questions on narrative, now I'm going to relinquish the floor. Okay.
All right, so as Ryan described, like a key part of this whole experience hinges on the player talking and us being able to recognize it. So when we started out working on this, there was a lot of research with the behavior trees and everything else, and then speech detection was also one of the key elements that we spent a lot of time just trying to figure out. We knew what we wanted to do, but we didn't know exactly how we were going to get there. But we knew some requirements, and so if you've ever used just Google Voice on your phone or whatever, it beeps. You know it beeps, and so we can't have a beep because that would totally break immersion like right away. The other thing we can't do is pause the audio thread. We didn't realize it at first, but later through some experiments and stuff, that with the on the phone voice detection, it actually pauses the audio thread. So what that means is that any audio that's playing in the background, like the record on the station or your producer talking, like that would just go silent anytime we were asked you to speak. So we couldn't do that. So another key thing is that you can't have a long delay, right? It's going to be weird if I ask a question and then wait, and then 10 seconds later he finally responds. That's just not natural. We were going for this conversation, and then also Sphinx is one of the options that we looked at. Is you had to train it. It was open source, but it was going to take like 1,000 hours to train this to be able to recognize everything we wanted to. And you had to put in specific keywords and stuff. And during the development, like those keywords would be constantly changing. So it was just going to be a no-win solution. So some of the things we did look at were so we looked at just Google Voice. We looked at like Sphinx. We looked at Watson. We looked at, can't even remember what all else we looked at everything that was available to us at the time. And Cloud Speech ended up being the best because it had the option of streaming. Like all the other ones took too long and had different things. But the hiccup at the time for us was that the only way to do it on the device is that if we made a Java plugin. So none of us are Java developers, but we through some help ended up figuring it out. And we ended up making a plugin that also recorded audio, so we could record different bits. So like in episode 1, you're at the radio station and you're speaking. And then later, if you play episode 2, and so we save that to your phone, and then we actually like play that back at different parts because you're listening to the radio there. So the huge thing for us though was the streaming part, and the only way to actually do that at the time was through the Java plugin. But now I think there's some options with updated .NET and stuff with Unity. I think you can do a pure C# solution. Go ahead. So this is basically what they give you back. So because you're streaming, right when you start talking, it starts giving you these partial results. And it's just like, they're not always really great. They could be like crazy things. And it gives you like a stability rating. So as you're streaming, you're talking, you're getting back all these partial results. And then you take a breath. And then that's usually when it like finalizes what it thinks is, then gives you a full result. And it also comes with, so the transcript is basically the string of text, and then the confidence is just the rating that it gives you about how confident it is about what you're saying. And okay, so this is how it was implemented kind of in practice. This is like the, so we would make all these regex things. So in this place, we'd make all these constants, like intro night owls, and we would put these like night owls, nice houses. So you had to like kind of test it a lot, and sometimes it would come back with these weird things like dash of the rest. So we had to also do like breasts and different things like that. So you had this like margin of error, right? That was like it wasn't perfect, right? But it ended up with enough testing you could like kind of get all the variances that what you might think with people's accents and stuff. So you kind of account for that. And then it kind of, how we would test it basically is we had these methods on a player speakability that just said, was this said and was this ever said? So we would keep a history of like all the results that were coming back, and then you could check against that. So like this, yeah, the intents, we just had these massive file per episode. So, Joe, do you want to take this, or do you want me to?
Okay.
Yeah, cool.
So kind of picking up where Brock left off, and also what Ryan was talking about, behavior trees were pretty critical to how we wanted to be able to handle narrative, meaning like we wanted to be able to pick up a cup, like Ryan was saying, and immediately derail whatever was happening and go somewhere else entirely. And if you're used to like finite state machines, that kind of jumping around and discontinuity is pretty difficult to achieve. And it turns out behavior trees, they're not hard, but it's also like, it's thousands of lines of code. Like it's as complex as you want it to be, but in our case, we had lots of different branches that we could explore. So it ended up being pretty complicated. But the basic concept of the behavior tree is really, really simple. You have a tree of nodes. So you start with a parent node, and then you have child nodes. Those nodes can do different things. Like they can be parallel, things happening at the same time. They can be conditional nodes. They can be selectors. They can be probability nodes. You can write custom nodes to do anything you want, which we have lots of. And then you can combine those, and you can have subtrees where you splice in a whole nother tree into another tree momentarily if you wanted to. Like, oh, this you know, a spaceship just landed, and the whole story is going to change now. Like you could just splice in the spaceship tree and go on a totally different thing. So it ends up being very modular. And if we tried something, a lot of what we did was try something and it didn't work, and we'd throw it away, which starts to get really expensive. But you know, if your development timeline can allow for that, you can get into some really cool things. So you have trees, you have nodes in those trees, and then nodes have three statuses. So a node is either running, it's either successful, or it's failed. And the idea here is that you're ticking the tree. So you tick that parent node, it ticks all of its children, and on and on and on and on, right? So each of those nodes can return a status, and based on that status, the nodes can do different things. So a conditional node that fails will not tick its children, or you won't get past that condition. A parallel node could succeed if one of its children succeeds, or it could fail if one of its children fails, or it could succeed if three of its children succeed. So like, it's very, very malleable. You can kind of do whatever you want. You can go to the next slide. This is the highest level tree in episode 1, probably. And you can see here that we're splicing in a switch statement. We're splicing in the different scenes. So that modular sort of code base that I talked about, this allowed us to be like, okay, I'm going to work on scene 1 narratively, and Ryan's going to work on scene 2, and then somebody else is going to take scene 3. That's super helpful. Whereas like if you were trying to just code up a finite state machine that handled all the scenes, you kind of have to go, okay, let's do scene 1. Now we know how that ends and how we're going to get scene 2. And in this way, we could kind of be modular about it. This is also super helpful for testing. If you're making a 45-minute episode and then like there's a bug in the last minute, that sucks to test, right? So in our system, we made it very easy to just be like, bam, 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 I'm going to skip to this scene, and then I can skip all this dialogue by hitting a button, bam, and now I'm 45 minutes into the episode in like 10 seconds, right? That's super, super helpful. So that's sort of just an added benefit. But the basic structure is there's trees, subtrees, and then, you can go to the next slide. There's a parent node stack. This is just, it's kind of hard to get into in this context, but basically what happens is any node type, so this is a sequence node, they just get thrown in a stack. So there's always a parent node and then children, and in this case, this is literally like a C# stack. So you push things to that stack, and then you can pop things off the stack. And it's literally just, ticking down that stack. You can go to the next one. This is a scene example from the game. This would be episode 2. And this is one scene out of, and in this case, this is like a sub-scene. So this is scene 5, the vigilante arrives, and there's like maybe 12 other scene 5, blah, 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 blah happens, right? So this is like a modular chunk that we could jump to. You see the first thing we have here is this condition with a scene state. This is sort of our own pattern, but we created scene states that we could say, okay, now we're in the part of the game when the vigilante arrives. And that means that if this condition is not true, none of this code is running. If it is true, potentially all of this code is running. The tick happens across the entire tree in every frame. So that's kind of a different pattern that it took us a while to really wrap our heads around, but it's super powerful. So in this case, we have these state conditions. These are custom nodes that we made. That's basically this character is going to say this thing, and then when that's done, the next state condition can run. So these are conditions based on, did he say this yet? Is it done? And then is that done? Is that done? Is that done? So they're kind of going back and forth. And then we started listening. We're looking for a particular thing. In this case, it's did the player say anything? We stop listening, and the scene goes on. So in this way, there's hundreds of chunks like this, where a new Amy would write a new thing, and then we could stitch it in pretty quickly and build out the scenes like this. Does that make sense to everybody? I know it's hard.
How did you do, so like up there you have conditionals that say, hey, has this line been set, then go to here, has this line been set, go to there. We were talking earlier about interrupting people. How would that work if you're in the middle of that stack and then the player picks up a cut?
Yeah, so let's say you have this sequence, and above this, the parent to this is a parallel node, okay? And then another child of that parallel would be a sequence about the player picked up the cup. So two things. One is that we can always be evaluating, even while this is ticking and doing its thing, did the player pick up the cup? Did the player pick up the cup? Every frame, right? And they pick up the cup, and what happens is we had requests to basically a manager. There's sort of a director standing over all the NPCs who says, okay, this person is talking, and it has this level of priority, potentially. In this case, there's like additional parameters that we could pass in to the say condition, but the idea was that, is this interruptible? And if it is, and then this is more important, then we're going to stop this guy and then let this guy speak. And that might be the same guy, same actor, but we're going to stop this thing and we're going to start this other thing. And then the next question is probably like, well, how do you know where to start? Because like for me as an audio guy, I was like, well, we can't just stop them mid-word. It's going to sound ridiculous, right? So we built out in JSON times that it would be acceptable to interrupt at, right? So you go through and you tag and you're like, okay, well, this is at the end of a word. It's a natural pause. You could stop here. So it's like, what's the soonest time that we can interrupt this? We hit that time, we interrupt you, and then this other thing can come in. And if abandoning this is totally fine, because when we pick back up the story, we come in here, these conditions will still be met. So it would just skip right through all this stuff and come back wherever it was that they were at to begin with. That has its downsides too. A lot of our bug testing was around why did this happen? Like we're supposed to, we did this and then this happened. And it's also the case that we test and we'd be like, I wasn't really sure what happened. I think he said this and then this, because like there's so many branching possibilities that it gets a little hard to deal with. But yeah, that's how we would deal with interruptions. That's, the system supported alternate versions of lines also. We only used it a little bit, but where like, if you interrupted a guy and then he went back to the thing, he could say, anyway, like I was saying about that thing, and then continue the line, right? Yeah?
Did you have to like hand build all those interruption points?
Yes. It's really cool. It's awesome. Yeah.
So with being able to interrupt, you talked about being able to jump back in, which requires you to keep a lot of state in memory, which is not a problem.
Sure.
But how does that then work with being able to test and being able to jump? Because you're talking about loading so much state into memory to get our way through one of these scenarios.
Yeah. So that exposes an edge where that is not easy to test. So in the cases where we had an interruption and then a bug happened, like we needed to get to that state, there's not really a great way other than just, okay, I can get right up to that thing and then I got to just do that thing and watch it. The other thing is that since this is all in code and there's no visual representation of it, like on a graph, a node graph with lines and stuff, debugging at first was really hard because you end up with a stack. I don't know. There's thousands of nodes, right? And they're all nested. I mean, it's just crazy to think about. So debugging became really difficult, which we made a tool for. You can go to the next slide.
I would say the main story beats had like a set amount of conditions. Like these 10 things had to be true. So you knew if you skipped there, you just set those all to true.
Exactly. Yeah, that's the other thing is that you could, with our skip key stuff, we could set certain states that we knew would be.
Well, I was noticing you had the has XYZ ever been said? Which
Yes.
seems like that would throw a wrench into it as well.
Yeah, it definitely could. And we could reset that manually. So in a testing rig, I mean, it can only get you so far, right? It's like, there's always those things. That's another great thing. I think I mentioned in the slide, but I'll say it in case I didn't, which is unit testing was really valuable early on, which also sort of gets into the need for pure C# classes because mono behaviors can't be put into a test harness like that. Unit tests early on, like if you have a node that kind of does what it's supposed to do, but sometimes it's kind of flaky, that's going to ruin your life for like a month, right? So unit tests around that kind of stuff will sort of guarantee, hopefully, that, okay, I changed this one little thing about this node, and then like the whole game falls apart. You would know exactly where to look if it was in a test harness. So nodes get ticked. This is sequence node, just so you can kind of see what it does. You can see that we bail with certain statuses. Otherwise, we return success. We had different, we called them different exits. This gave us a lot of flexibility in thinking about how a sequence could work. Like if a child failed, do we care about that, or can we just move on with another sequence, that kind of stuff. But all nodes have a tick, and they all implemented like an interface that all the nodes would implement. So it ends up being really simple. So it's one of the strengths of the behavior tree is that you have very simple modular code that sort of gives birth to this really complex, almost emergent behavior. Next slide. This is another scene example. It's a little more complex, as you can see. Basically, in this case, we just had these like do ifs that, okay, if something is true, like if they said something about, what are they asking? Oh, this is about advice with like, for kids. Like, hey, I'm gonna have a kid, do you have any advice for me? And then we had different answers. So if you said poop, we could take the poop track and then like have a switch statement that would give you the poop response. This pattern we ended up using quite a bit and is a really powerful and also very explicit kind of pattern that, if Amy was like, oh, it'd be so funny if we added this one thing, no problem. We'll just drop in another if statement, we drop in another state condition, and go about our merry way. So this ended up being really great.
How could you go about finding what were the most likely responses that you could?
Well, we did some improv with each other.
Yeah.
So one of us would be the player, and everybody else would play all the roles, all the NPCs, right? Mm-hmm. We probably didn't do enough of that, I'd say. You could always do more of that. Just testing outside of having to build it in the game before you know that. but yeah, that's pretty much how we did it. And also Amy is I think, really talented and funny, and found a way in most cases to, well, in most cases, like, so in this case, there are pretty common things that you would say about having kids, if you have kids. And then there was usually also like a generic answer that we could just sort of bail out on. And then if you didn't say anything, there's always the case where the player just sits there, or like the internet stopped working and cloud speech doesn't work, right? The game can't just be like, oh, we can't do the game anymore, sorry. So like we could sort of just bail in those cases if it was taking too long. So next slide. I talked about visualizing this stuff. This was a little complicated, but it's not really that hard. And I'm kind of the studio tool guy. I like to make tools. So this is basically a scrubbable history. You can like scrub this guy back and then see all the frames that led up to a certain state. This is the entire stack of nodes. Red means it failed, green means succeed, gray means it hasn't been ticked. And then this guy means that it's running. So like we're running this parallel node, all these succeeded, now he's saying this. And what this ended up helping us do is like, okay, it broke, I don't really remember what happened, but I know it's broken, so I'm gonna pause, and then I can scrub back in history and see how the tree evolved over time, and how did we get to this place. Without that kind of tool, you're gonna get lost pretty quick. But also the tool didn't always work, so I had to be that guy. Yeah, next slide. So there are alternatives. Ryan mentioned Node Canvas. Behavior Designer is another one. And that's a graphical approach, a graph with nodes and lines and lots of spaghetti. If you're a programmer, you're probably not going to like that. We started with Fluent Behavior Tree, which was a super simple sort of library. I mean, I don't even know how many classes there were. It's like a dozen classes maybe. Super simple. It was very easy to get going. And now if you look at our code base around trees, it's evolved a lot since then, and there's hundreds of different things that we do. Unit tests are going to be valuable. And then behavior trees are super powerful outside of narrative design. We chose to use them for narrative, but also, like a lot of people, the most common case is you're making a game where you kill each other, and there's an enemy and he's got to chase you around, and like a behavior tree can do all the AI for that guy very easily. So that's kind of what that's used for. I think that's it on that. Okay, I'm the audio guy also. So sound design. And then I thought of a couple other things that are super important we might be able to get to, but if you're making a VR game, use positional audio. And positional audio means it's positioned in the world, not just left and right of you, but elevation above or below also, and behind you, right? So like, and I faked this in that Dragon Cancer because it just bugged me. I couldn't live with it. Where if a sound was behind you, it shouldn't sound like I'm looking in that direction, right? It's behind me, and like your ears don't work that way. The arrival times and how it's filtered and all that. So with positional audio in VR, you have elevation, you have the idea of something being behind your head, and you really should use it. And I've seen actually probably most of the VR things I've tried have stereo sound, just regular, oh, that sounds over there, that sounds over there, but like the idea that, oh, this bird just flew over me, but it sounds like it kind of flew through my head, like it's on the same plane as me, it just isn't good enough. And if you use positional audio well, it can make VR, I think, really outstanding. The immersion of it is way, way better. You have to have headphones. So if you want to make a VR game and you don't want to use headphones, you may not want to make a VR game. So that's just the state of technology. It's not possible currently to play back over speakers and have the kind of control you need to make positional audio work. This gets really platform specific. So depending on your target platform, if you're going to ship on the Rift or Vive or if Daydream or Gear or Go, or like there's lots of platforms now. I believe the current state of things, and I might be wrong, but based on like where I think things are at, you can use either of these that I mentioned, Google Resonance or the Oculus Spatializer, for any platform. I should qualify that. Mac, PC, Linux, iOS, and Android. So that's great, because when we were making Untethered, the Daydream Spatializer stuff was totally specific to Daydream. So if we wanted to ship on Gear, I'd have to redo all the sound in the game. And the tools that you use to do that, it's not, you don't get to use just the Unity audio source. They have their own audio source component. They sort of build on top of Unity's audio system. So Resonance is super cool. The Oculus Spatializer is also very good. And then just be wary, like you're gonna have to do some research. If you wanna make a cross-platform VR game, know what you're getting into, balancing all those different classes and stuff. Asset prep is really important. It always is, but if you have a sound guy, or if you don't, you should know that positional audio, almost everything, if it's going to be positioned in the world, it should be a mono asset. If it's stereo, it'll get baked to mono at runtime, and you're paying CPU for that. You're also taking up RAM unnecessarily. And then there are some other formats which I can talk about. Complex sounds are better, and what I mean by that is if you picture a sine wave, just like a constant tone, it doesn't have a very complex sonic signature to it. There's not a lot of frequency content. You get this one spike at like 1K or whatever. And the spatializers, the way that works, it uses HRTF, head-related transfer functions, to filter sounds. And if the sound is too pure, that filtering actually can't happen because there's nothing else to filter. So you won't really get, like if I tried to position a sine wave in a world in VR, you'd kind of have a vague idea of where it was, but you'd have a hard time putting your finger on it, as opposed to like a train, which we have in Untethered. A train passes in front of you, the complex sound of a train whistle, that kind of thing. That spatializes really well because it can be filtered really well. So complex sounds are better than more like pure tones. Ambisonics is, it's actually a format created in the 70s by some people who were way ahead of their time. But it's now actually becoming a pretty cool thing. Ambisonics is just the idea that you take a sphere, and you're on the inside of that sphere, and then you can put a sound on any point inside that sphere in a volume, right? The downside is that you can't then move a particular sound across that sphere. It's because it's baked. It's like a surround sound kind of, but on a sphere. So that's super cool for backgrounds. So like distant things that aren't going to move, but are going to stay kind of where they are. And both Oculus and Resonance have support for ambisonic files. Resonance can actually bake ambisonic files. So you can save yourself resources basically. Instead of using a dozen or 20 mono sounds, you can, if they don't need to move, you can just bake them as one ambisonic sound. And then that gets compressed, and it's a lot less intense. Sounds change when they get positioned. It's going to sound different. So your audio guy is working in their software. It sounds great. They put it in the game. It doesn't sound great. So just like getting in the headset to see the world, you really have to be listening to it at runtime on device to understand what it's really going to be and how it actually sounds. Cool. I'd encourage people to be creative. I had some fun with the idea, like our menu stuff. When you start the game, we start with music that's on the radio. So you're in a radio station, and like the guy before you, they play their last tune, and then you come in. So as you come into the game, you're hearing that last piece of music, and it's in 2D because you don't see a world yet. You're just seeing like text, like, hey, we're loading the game. And then when we fade in the world, I faded that 2D sound out and faded in a positioned sound of that same sound, right? So there's this kind of cool effect of it's going out of your head, now you're in the world. Sort of like waking up into a dream or something like that. That was a lot of fun. You can move sources around. Moving sources help localize them. So if you have a sound that's static, the spatial resolution of these things is actually not that great. The best you can do is about like a 5-degree offset. But if you move it around, now your ear has more information to work with, and it can do much better knowing where that thing is. And then add sounds that don't have visuals. So if you're in a forest but there's no birds, like, is the forest dead? What's going on? Like, put frogs, put birds, put whatever, the sound of wind, a distant waterfall that you can't see, whatever it is. Like, build out the world, add to the world with your sounds. And that's something that obviously outside of VR is super important too. But in VR, because it's positioned, can really help sell the immersion. VR is the Wild West on all fronts. Like, everything is changing all the time. So just know that, and know that you're going to have breaking changes. So like, hey, the game sounds great. And then like, I want to say like a day before we were shipping the first episode, Google shipped a patch to Daydream that broke the entire audio system. And we listened to the game and it's like, everybody's looking at me like, what'd you do? It's like, I didn't do anything. But just know that kind of stuff's going to happen. And you know, it's just what it is. And I'd love to help you. And that's my email address. We also will have a link to this presentation so that you have all the links later. Any questions about sound?
Yeah, did you use Steam for anything, like Steam Audio?
I didn't. I'd like to. Steam is doing some cool stuff. In particular, they're doing, they have some physics-based, like modeled sound environments. Daydreams, or Resonance, as they call it now, is starting to do the same thing, where you have, you can associate materials to, you can associate physical attributes to materials in the scene. So like this brick wall, I could describe that in terms of sound and then bake that, which is super cool. So Steam Audio has some stuff like that too. I don't know if you can go to all the platforms with that SDK or not. It's a good question. I don't know.
What about occlusion and attenuation?
Yeah, so both Resonance and Oculus Spatializer deal with occlusion. Occlusion is when like I'm talking and then I move here and like now I sound different. It's super crude. It really, what it is it's kind of on or off, like line of sight on or off kind of a situation. That bugs me. What's that?
It's with Resonance, you said?
Yeah, with Resonance. The Oculus Spatializer, I think, is a similar situation. It's basically line of sight. It's like line of hearing, but it's just a raycast, right? So does this thing have a direct line of sight or not? And then you filter that sound. It's a low pass filter, and you duck the volume a little bit, and now it sounds like it's behind something. But that can be super important in some cases. Yeah, that's a good question. Any other questions? Sound?
Did you use any other like tools than Unity for audio or middleware or any extra stuff, or was that all directly?
Yeah, we haven't used any middleware. I don't really have a great reason other than when I started, middleware made it harder for me to get work.
Yeah.
So like you go to a client, well, I can totally do the job, but I need $2,000 for FMOD,
Yeah.
and then I can do the job. It's like, that's not going to work.
But like the spatialization is a separate kind
Spatialization
of
is, it is. So in Unity, There's also Unreal versions of both those things. In Unity, you choose a spatializer,
Yeah.
and then the audio source has a pan slider. Is this 2D or 3D? And it has a checkbox. Is it positioned? Is it positional? And then it'll use the spatializer to do all that stuff. They also have tools, VST plugins for your DAW that you can preview those sounds, so that, like, if the audio guy isn't in your game environment, that's how he or she should preview what's going on. And then Ryan had mentioned some stuff about audio performance. Like, don't reference clips. Like, don't drag an audio clip into an audio source in a Unity scene. I can get into that stuff, but maybe if you're interested in like how to deal with that, I should just make time for the other stuff, and then you can ask me once we get through everything. Cool. Awesome. Is this you?
Yeah. Let's see. I think Ryan pretty much covered everything in this. No worries. One thing, I guess, a couple things. Sensor drift over time in this with the mobile platforms, you would have to recenter after a while. That's kind of something can be interrupted. Oh, I guess the other thing is from a code side, like, we were super careful about garbage. Like, you couldn't create garbage because once the garbage collection kicked in, the game would like hitch, and it would just be bad. Your frame rate would drop for a little bit. And
everybody know what garbage is? Okay,
cool. Yeah, go to the next one. Cool. So before I get into some code stuff, what I would like to say is that I think it's really important to choose tools and techniques that play to your strength, right? Everything that we've shown here today, we chose because that was played to our strength. So we chose a code-based behavior tree system because most of us know how to code and we're good at it, and that was like the most efficient way for us. Similar things with like some of the art style choices and stuff, right? Like, it's important to play to your strengths. Like, it doesn't matter if somebody recommends something and like if you're not comfortable with it, like, it's a huge problem. And I think anything that you can do to speed up like the development cycle is really important. So that's kind of why we made some of the choices that we made. So this is going to be like a really nerdy code section, so you can tune out if you want. So saying all that stuff about, choose whatever you want, I hate a lot of things about Unity coding, and so I've come from a lot of different game engines and languages and stuff, and this is the only way that I've felt totally comfortable architecting something in Unity. So Zenject is a dependency injection framework for Unity. Next slide. And so what's dependency injection? It's just a code technique where one object supplies the dependencies of another. So next slide. Okay, so simplest terms. So this is kind of like the normal workflow in like a Unity class, right? You have a worker, and he needs a tool to do work. So you usually like assign it in the editor, or in like an await function or something. You can go get it if somebody forgot to assign it, or if you'd rather do it that way. And then when you call work, you use the tool. So all dependency injection is just passing in what it needs to actually do something. So a worker is dependent upon its tool to actually do work. So it just passes it in. That's the most basic form of that. So what are some benefits of using this? Singletons are super easy and clean. Singletons are kind of goofy in the normal Unity setup, in my opinion. It encourages modular code, which makes refactoring a lot easier and unit testing easier, because you can write a lot of C# classes and you don't have the overhead of mono behaviors, where a lot of times you don't need mono behavior functionality. It also makes using interfaces really easy. So we use a ton of interfaces in this, and we can talk about that in a second. So this is kind of like how it works, so in the dependency injection framework, you have this thing called an installer where you make bindings, and once something is bound, you can basically just ask for it. So like in that worker example earlier, if you bound tool, you could just create a new worker class and the tool would be provided. So in the case of like, if you want a singleton of something, let's say you have a game class and you want it to be a singleton, all you do is just say as single, and then it's a singleton. So then you can have specific injections into other classes. So if you have a game settings class, you can bind it into the game class specifically. You can bind interfaces, and you can bind things that are on like prefabs, just like you normally would from like resources. Another cool thing you can do is like you can make something that's transient, which just basically means it just gives you a new copy like each time. It's a separate instance. Next. Yeah, so this is like a pure C#. Like I said, we use a lot of C# classes because you don't need the mono behavior for a lot of stuff. So, so this is the director class. This is what the constructor looks like, right? We talked about this earlier. The director basically marshaled all the different minds, and they were asking for to be able to speak. And so we just gave it this list of minds, and it was different for each episode, right, in each scene. And then the player speak ability. But the cool thing is, like I said, with the interfaces, we programmed a lot of things to interfaces because then you can just swap out the classes. So all our input for all our VR stuff is programmed to an interface, so we can much more easily move it to a different platform. Same thing with like these minds and stuff. Going to the next thing. So you also can do this with like mono behaviors. So this is our player, and he had eyes, a hand, and an input. So his eyes were like the camera. The hand basically controlled like the pointer, and like we had like a state machine for like different abilities and stuff. Yeah.
I don't know if you're inject this or not, but how do you ensure that the injection is happening before you run out of
So basically, it's guaranteed so at this point, like if it gets to, like if this is instantiated, so all the bindings take place ahead of time, and you can validate them in the editor too, so you make sure all your bindings are good. But by the time it gets here, you can guarantee that it has all those, or throw an error like right away. So I think that's it. Cool. So I'm happy to talk more about this because it's really complicated subject. If you want to argue, just buy me a beer first, and then I'm happy to argue about code. Any questions about this, or come see me?
Why not do it in the constructor? Like why?
What's that?
Why not do it in the constructor?
For which one?
For the previous one?
Oh, the previous one, because mono behaviors don't have constructors.
Oh, I see.
So you have to, yeah, so you inject it. So this happens like before the awake or right after the awake. I can't remember the order for like before the awake. Yeah. So even before, the awake happens, you can count on all that stuff being there. So, yeah.
I think one of the biggest benefits of that is that Unity has a way of losing references to stuff. Where like if you just make a public field and you attach a reference, and then maybe the artist brings in a different model, like the whole setup changes, that whole thing goes away. Now the reference is gone. And in code, the way our installers work, you could sort of guarantee that if this thing is in the scene, that it's going to get bound, it's going to be binded into a given class. And there's lots of cases that we ran into where serialization just kind of screwed us. Complex setups would get lost. So we moved a lot of stuff to JSON, and also this pattern of dependency injection prevents us from having to store all these references in a scene.
I also think it's, as a coder, it's easier to reason through. Like, I think anybody on our team could open up and see exactly what's happening and trace the dependencies throughout, like for the architecture wise. So cool.
All right, I'm Mike. I'm also on the Numinous Games team. Who here is a QA person? Yeah? Matt?
I've done some QA.
Cool. I was pretty much expecting almost nobody. How many of you like QA? All right, so I'm a developer by trade. I started my career as a developer. I moved into more management roles and then eventually did a lot of project management and managing teams of QA people. Anywhere from 10 people here locally to 20 people in India. And they're working completely separate hours that we are and just managing that relationship. So when it came time for us to deliver and actually test this stuff, I raised my hand and said, yep, I've done it before. I'll be glad to help us do it now. So I'm going to talk a little bit just about general QA and then some of the things that we did specifically for testing VR. I will say right off the bat, testing VR is, I think it's really tough for just a QA team to do. I think it does involve a lot of the developers to really get their hands dirty and do it. That's why John built some of the tools that we were using to help test. Me being able to go into the editor and trace things down was really critical. So I think it seems to be, so far, it's a lot more technical because the tools just really weren't there to test it the way we wanted to. So we're going to talk about requirements for what our QA testers did when they were coming up with the requirements and kind of digesting the requirements we gave them. Internal testing, external and end user testing, and then how we kind of track and report it. Next slide. All right, so first off, is QA involved in design? Even going back to any of the software I've ever developed, if QA is not involved during the design, it usually is a much bigger deal. So it's super important. If you can get your testers involved during design, it's going to make a big difference. So after that, you have kind of an onboarding process. Get them testing. So our testers came in later, which we on this project specifically. On our next VR project, we had them in a lot earlier, so it went a lot smoother. But get them into the environment. So get them testing it right away. Figure out what kind of things they're coming across. What problems are they running into? It's a great way to do kind of your initial end user testing because they've never touched it before. We came up with a reporting process. So what is critical? What is high? What is medium? What is low mean? How does that determine what we work on? Things like that. And like I said, it's a great identification of early issues. Also, we had them basically kind of QAing the requirements. So as they were kind of taking in all of the scripts that we were writing and all the code and all the game stuff they were playing, they would tell us if there was something wrong. Like, hey, this script doesn't match the implementation. Is it an issue with the requirements or is it an issue with the code? And we would iron out a lot of those issues too. In the VR project that we did after Untethered, we actually were working with a client and it was helping us get our scripts right before we even sent it off to the client for review. So we kind of had this like pre-QA check on everything that we were doing. Next slide. So internal testing. So we did a lot of just critical path, happy path testing. Usually every time we get a build, the first thing is critical path test. So what is the critical path test? We went through and defined, this is how you get through the game. We also call it a happy path. This is how you can get through the entire game. So that's the first thing we always test to make sure that we can get through the game. Or whatever thing we're testing. If it's just one of the episodes or if it's a section or whatever, we have a happy path. We also do a lot of out-of-headset testing, which is where we just pull up the phone and we just look at it because putting the headset on and off to check against the script is a total pain. So being able to test outside the headset is absolutely your friend, even though you do need to do a lot of in-headset testing as well. So yeah, our outside of headset was kind of the main way that we did a lot of our acceptance testing, all of our additional path testing. And the way that we did that was we used a tool called Reflector, which works now for iOS and Android. That basically shows what you're seeing on the phone, on the PC, and then we use ScreenFlow to capture the screen and also did an ADB logcat at the same time. So we're getting our logs, we're getting what they're seeing on the screen, and we can kind of match those up. And then we record that session, and we can see exactly what's happening when. So in the headset testing, there's lots of different ways that you can do this. The main way that our QA decided to do it was to pretend like they're different types of players. So I'm a brand new player. I've never touched VR before. I'm going to be super clumsy with everything I do. I'm going to drag and drop everything in the scene and see what happens. We're going to do the same type of thing with kind of a confused player, and then we're going to go through and play like we're an expert. Like we already kind of know what to expect, and we're going to play through it, and that's more like the happy path testing. We did a lot of also external testing. So we've done controlled external testing and uncontrolled external testing. One of the things we did is we used a service called Fishbowl VR. And basically their entire existence and their business model is that they want to help VR companies test their content. So they have this whole group of users that have different devices, and they've signed up to be testers. And they do it for on the cheap, but really they do it because they want to get a bunch of free VR games to play. But it turned out to be extremely valuable. So what they end up sending us is a video of them playing the game and a picture of what they're seeing, and then their commentary throughout the entire game. So we can kind of get an idea of what does this user that has never seen our work before think of the game in whatever type of run through that we want to do. And so we went through that a couple times with them, got some great feedback, and to me it was very beneficial, and it wasn't very expensive either. We also did a lot of just open room stuff where we went to either conferences or we had open houses, and we would just get people in, have them put headsets on and play it and see what happens. We want to continue as kind of a philosophy of our studio to do this type of stuff a lot with anything that we're working on, even in the prototype phase, and we think that that's really, really important to get a lot of good feedback. One thing that we did with Untethered is we also worked with Google directly, and they did a kind of a closed environment customer survey test. So they brought people in, they let us kind of watch a live feed, and they would actually sit down and play the game. And some of them had never touched VR before, some of them were VR enthusiasts, and we got a lot of really valuable feedback from that too. So test all the time. Next. And then we have tools for tracking and reporting. We started off back in that Dragon Cancer days using Trello. We then transitioned over to something a little more robust like Asana. Both of those tools are free. Asana was something we were on for quite a while, especially through most of the development of Untethered. And then more recently we're using tools like Jira, and we're starting to look at some of the kind of sprint planning and task management things that are on GitLab. So there's lots of different tools that you can use. There's hundreds more than just the ones that we chose. These are just very common that we've, as a group, have had experience with before. With QA, it's always important to do daily triage, weekly triage. You want to get with your QA group. You want to have somebody kind of dedicated to report with them and work with them, go through the new defects and bugs that have been found, prioritize them, and then get that list to your development team so that they can work on it in the right order and be efficient. It's always good to kind of set up that process and make sure that that's part of your normal development process. And then you can also do some reporting based on those and get some trends. Is the builds more or less stable than they were before based on how many bugs are coming in? Things like that. Anything? There we go.